in alignment and shorten the distance to the plan. Wish we had a fortune teller crystal ball in hand, cause can't see in the dark, not even retina scan. Deep in the future, we dig a hold of the prospect. Something toxic got in with foreign objects, war and problems we gotta get over. This affects the whole, we can't split soldiers. The last remaining, if we stop fighting each other, we might actually save it. It's difficult when we're all apart to make it easier. The enemy invited us all. Now that we stop the bickering, we get double crossed by attractive trickery.
How much we care. No, not a lot. To be free, gotta think out the box. Outline, apply, use cunning or be shot. Space, we continue to fight on and right the wrong just to keep the lights on.
Hey guys, I'm a little biased, but that's my favorite gaming intro. I'm James Dwyer, and I work for Gearbox Software. We make video games, and as some of you might know, making video games is pretty awesome. Last year, we made a game called Battleborn, and today I'm going to talk about how we migrated Battleborn into using GameLift from Amazon. It started with a spark, an idea, or technology, and specifically, one of the founding principles of Gearbox Software is that we aim to entertain the world. It's seriously highlighted in every one of our company meetings. Every feature, every decision, every project is measured against that. Is it entertaining? And today, I'm going to show you how to make your games entertain the world, how to save money, how to entertain the players, get them into games faster. Using GameLift, it's pretty awesome. Gearbox Software released Borderlands in 2009. It focused on a fundamental cornerstone of entertainment, that everything is better together. It was just more fun playing, fighting, and looting with friends. In 2010, reacting to the positivity that our players felt for cooperative gaming, we created an almost renegade group within Gearbox called Spark. It started as a kind of a set of guidelines and the basic infrastructure for a cloud toolkit. It had some services, authentication, accounts, redeeming codes, telemetry. The end goal was to better enable our players to have dynamic changing gameplay. We released Borderlands 2 in 2012 with the first version of Spark. But even outside of Spark, Gearbox really stepped up in their cooperative game and like main menu access to your friend's status and drop-in, drop-out multiplayer. And over the years, it had such a great reaction. We got hundreds of emails from people that were just so happy to be able to play with their friends online and connect over long distance. It was so gratifying to hear these stories, some happy, like people who met, fell in love, and got married playing Borderlands, and some tragic, like people that had fond memories of playing with a family member who passed away. But the most important and frankly magical thing that was happening was that we were seriously fulfilling our mission, entertaining the world. We continued to build upon that mission by adding tons of new cloud tech and services to Spark, easily multiplying several times over the number of services that we support. And in 2016, we deployed all this tech in our new game, Battleborn. We dove deeper, flew higher into the cloud, I guess. Battleborn was a different beast altogether. It was completely dependent on Spark. If Spark went down, players would be unable to play the game. This is a new world for us, games as a service, games in the cloud. And there's this cute little guy who can resist him? He loves the cloud, so we had to get Battleborn in the cloud. And everything else, it's a whole new word, and everything else has services like electricity, Wi-Fi, internet, too many streaming movie services. Beer has a service, that's great. Pizza is often held up as an example of a service, but doesn't have a service, but I think it should. Why not games? Our game was a service. We had to really step down and do all these things. A lot of people think that games as a service is just like microtransactions, but there's a lot that goes on to entertaining players and make sure they have a good time online. Today I'm going to talk about how Amazon helped us do the highlighted green ones here. We were kind of a pioneer with using GameLift, one of the first to use GameLift end-to-end. And we naturally had some first version issues. And Amazon was very receptive to fixes, and even now, 6 months later, they've added a lot of features that really helped us and really spoke directly to our implementation. So I'm going to show you some GameLift tech, as well as some of the ways that we customized it to take it further. So in order to fully understand the process flow, we have to understand what GameLift is and what it does. The official description is simple, fast, cost-effective, dedicated game server hosting. More specifically, it allows 2 or more geographically separated players to connect in a neutrally hosted server. And Amazon gives you all the tools that you need, APIs to connect it all together, easy-to-use SDKs to wire it all up. There are a lot of benefits to hosting your game servers on dedicated servers: fair connection speeds, security, fast and consistent hardware, solving NAT traversal issues between clients. Amazon really provides these features. I mean, you could do this with EC2, but they have a really games industry focus for this. You can find servers based on latency. You can manage game and player sessions, and then scale based on what's happening in your game. So the basic building blocks of GameLift are the build and the fleet. The build is just kind of a specific version of your game server. It's your bundled executable and content. You put it together, upload it to a region, and you got your build. And then a fleet is a deployment of those builds. So you could have a Windows or Linux deployment. You could have So each time you deploy a build to a fleet, Amazon will spin up a number of instances that each host one or more game server processes to run this game session for a player. The separation between the fleet and the build allows you to have different configurations for different performance needs that you might have for your server, or different hardware. You could run on different hardware. And that's really just the basic features of GameLift. Now we'll get to the process flow. So at the heart of Spark's game server infrastructure is a service we call Zeppelin. Zeppelin shepherds the players into the cloud, provides them with game servers, and manages their experience during the entire lifecycle of a game session. And it doesn't at all crash. Forget everything you've heard about Zeppelins. This Zeppelin does not crash. So at first, the client builds a team of 1 to 10 players. Then it asks Zeppelin for a server, because it's got players ready to play. So it has to ask Zeppelin for a server to host their game session. They may or may not be required to vote on options for the game, like what kind of map they want to play. Once Zeppelin knows that all the players have connected and all the players have voted, it can ask GameLift for a server. Now this is important to wait for that point, because we don't want to allocate a server and have the players be like, just backed out. We need to make sure every player is ready to play before we ask GameLift. Then GameLift looks at all its fleets, finds a process to host that game session. Then it activates that server process. The process then will prepare for the game session. It may load player assets, map assets. It may get player stats. Then it tells Zeppelin that it's ready to go. So at this point, the server is ready to accept player connections. So the players, meanwhile, have been asking Zeppelin for information. They've been saying, hey, where's my server? Where's my server? Zeppelin's like, hey, it's ready to go. Notice how the clients never talk directly to GameLift. They only talk to Zeppelin in the game server. This creates a kind of abstraction layer between, or yeah, they connect and play. This creates a kind of abstraction layer between the cloud and the game client. So we can change everything to the right of this blue line, and the game clients don't even know the difference. In fact, that's how we launched GameLift into Battleborn, was a seamless launch. Players didn't notice. They're on one service, and now they're on GameLift. It's kind of a lot of integration to coordinate and manage all those players, 10 players through this process, and you got to do it once, twice, hundreds, thousands of times a second. And these players are relentless. They just won't stop. As you know, if you've launched a game service, they just want to play and play and play. So we want to match them as quick as possible. We want to make sure that after step 2, after they've voted, they're ready to go, we need to get them their game server. So how do we make this fast? So one thing to do is focus on server activation time. You can do things to make the server activate quickly. And this is the time between when GameLift says, hey, server, you have a session to host, and the server goes to Zeppelin saying, I'm ready. So a lot of stuff could happen between that time. You could have already preloaded assets. You could have make parallel network calls so that it's quicker. You could pre-authenticate the server so it doesn't need to authenticate at that time. You can pin processes. Every second shaved leads directly to player happiness. You don't want that happy guy turning into this grumpy man here. With Battleborn, we gave it 45 seconds before we timed out. And on average, it happened in 15 seconds. So a lot of Battleborn's a big game. A lot of that time was spent loading. There's 10 players. You have to get all their stats and all their data. You have to load the map up. And you have giant maps that they're running through. In our new title, we have a 2-player game. Less players, it's much faster. We got that down to 5 seconds. So that's almost to bare bones Amazon time. Amazon's so quick. You request a server, they will return it so quickly to you. But there's such a thing as too much of a good thing. When we did a lot of these, and we had a lot of servers activating at the same time, they adversely affected other processes. So three server processes starting on the same Amazon instance would slow down everybody else. So you can fix that by configuring a limit for max concurrent game session activation. It's a setting under the fleet configuration. It's kind of a mouthful, but with this you can limit it to one. So here we've got it just one starting at a time. And Amazon will make sure that it doesn't overload your instances. Now that you understand the basic process flow and where the best point where you can influence the speed of getting servers to players, let's take a look at some of the cool stuff we've been able to do. So at Gearbox, we're always trying to find a way to turn the entertainment dial to 11 for our players. And one of the very first kind of design decisions we made was that we wanted to have no planned downtime. This is very ambitious because even top online games have downtime, many of them weekly. And when they do have downtime, it's often down for several hours. So let's assume for a minute that when playing our game, a player's entertainment value is 1. We're not playing, their entertainment value is 0. But let's be honest, they're probably on the forums raging at each other, raging at the developers, so their entertainment value is negative, but for this exercise, we'll assume 0. So this is a graph of alternative brand on patch day. Players are playing, they're happy, all of a sudden everything's down, they're unhappy. Battleborn stays at a 1 the whole time. That's a little tongue-in-cheek, but the principle is that to us, when we looked at how to entertain the world, we kind of thought one of the ways maybe don't turn the entertainment value to 0. Seriously, here you can see a transition phase. We have old build going to new build. You can see the blue old build, people are playing on it, and the yellow new build, people are playing on it. It seamlessly transitions over to the new build. So people playing on the old build continue to play. They're happy. They're just playing their games and their matches. We've deployed the new version. People that have updated are starting matches on the new version, and they're happy too. As soon as the other players quit and restart their game and patch, they'll be on the new version. So everybody's happy. And you can see that it wasn't even a couple days we let this old build run, because it wasn't that urgent that we forced people to upgrade at that time. So why not players have fun on their own time? Zero downtime really works to surprise and delight players. We launched Battleborn with this kick-ass prologue level that I showed you before the talk. Had a song by Deltron 3000 and Del the Funky Homo Sapien. It was awesome. He wrote that specifically for the game, but we only let players play it once. We just let them play the prologue, and then they had to play the regular game. They couldn't replay the prologue. So 1 week after launch, we used zero downtime to change that and fix it. And so all of a sudden, the prologue was replayable. This Kotaku article, a games industry site came out, and he said, so stealthy, I didn't even have to reboot. It was great. Zero downtime really creates this dialogue between developers and players and makes them feel like they're part of the connection. They're part of this back and forth with developers. So now that we know we want this zero downtime unicorn, how do we get it? Well, it took a lot of preparation. Of course, Amazon provides some cool tech to make it happen. First, your services could be versioned and stateless. These are kind of best practices for services so that you can run 2 versions at the same time. You can stop and start them at will. Doesn't matter. We use CloudFormation and EC2 containers or ECS containers to make that happen. The containers allowed us to have many versions of the server running at the same time. A simple or NoSQL database with normalized data models. You don't want an update to have to update a table in like MySQL and take 20 hours to update the table, because you may have to have downtime if you didn't do that. So those are some best practices. And then the other things you can do is you can have client patches as well as hot fixes. So we have the ability to hot fix a game. And that allows you to turn off a feature temporarily if it really needs some downtime, but the rest of the game is playable. And then the last piece is what I call the server cloud swap. Now, Amazon doesn't call it that, but I call it a cloud swap. It's fun. So you just swap out a cloud instantaneously. And you could do this with GameLift using aliasing. So alias is a name that's dynamically linked to a fleet. You can swap that fleet in and out, doesn't matter. When a game client requests a game on an alias, they'll get whatever version's currently out there. So we could have an alias for born to battle, which if they request born to battle, it returns version 1 of the server, and then swap it out with version 2, and clients are now suddenly using version 2. But we wanted to do a little bit more. We wanted to have something a little more powerful for our cloud swap. But we need to talk about configuration for aliasing first. So there's 2 types, simple alias and terminal alias. So simple alias is just your standard alias that points to a fleet. You can switch it any time. A terminal alias allows you to kind of turn off an alias, and it'll throw an exception and tell your client why that alias is not available anymore. And you can configure them giving a name, description, a type, and an associated fleet. And if it's a terminal alias, you give it a string to tell it why. So maybe your alias is down because new version available. So we want to do something a little better. And we set up a worker in Zeppelin to synchronize that fleet configuration with GameLift. So as you can see in this one, Zeppelin sees in GameLift 2 versions of fleet, Fleet V1 and Fleet V2. So Zeppelin has a near perfect knowledge of what the GameLift configuration is. And we can make these singleton workers so that they don't overwhelm the servers and keep track of it. So here's a simple version of how we can swap. So we have client V1 going to fleet V1. So the client version 1 starts and he requests a V1 fleet and he gets a V1 fleet. Client V2 starts, he requests a V2 fleet, he gets a V2 fleet. But let's say we want to point the V1 players to V2. So we can just update the redirection, say, hey, V1 automatically goes to V2. And now we've updated the server behind the scenes seamlessly so that clients can now connect to the new version. And we can support the basic alias case too. Oh, I guess that was sorry. Yeah, the basic alias case is redirects them to version 2. And we can even take that further. We can create a QA filter that says, hey, if you're a QA player, clients go to V1, but QA wants to test V2. So if you're a QA player, the redirection filter says, hey, let's try out V2. So the V1 clients are playing happily out there, unaware that there's a new version waiting for them in the wings. And then when QA approves, we can swap them over, so now the clients are using V2. So you can have QA approved cloud swap. 0 downtime. The filter is already pretty powerful, but we can have it do even more for us by helping us do fleet optimization. Now, when working with fleets, you're going to want to get the most bang for your buck. You may have some game types, even within the same title, that perform better or worse than others. Wouldn't it be great if you could just always use the most optimal fleet for every configuration? Yes, James, you say. It would be great. You know what? With a bit of work, we can do that. We're like hunters, and servers are literally our game servers. Therefore, we want to use as much of the animal as possible. We want to use every bit of CPU and memory. We're paying for this, so we want to use it all up. So we can do that by using multi-tenancy, more than one game server per AWS instance. There are 2 different ways to configure that. You can have multiple configurations. You can see there's 2 entries here. Each one has a different port and 1 concurrent process. So this will result 2 processes running on the same instance. Or you can do a single configuration. This one has a port range instead, but it runs 2 concurrently. So both of these end up with the same thing of 2 processes running on 1 server. So how would you pick between single and multiple configuration? Well, we liked the multiple configuration because we didn't want to have the server processes communicate with each other to figure out which port that they should run on. So we had multiple configurations, and each one passed the port that they should run on. With single configuration, if your servers don't care which port they're running on, or they can pick it by themselves and federate between themselves which port to use, you can use single configuration. And it's probably a little bit simpler to use that. Now, how can we most efficiently pack these processes? So these are the steps that kind of work for us. You can optimize memory and CPU, even if your game is ultra fast, your CPU will top out if you run out of memory. So we had a situation where we made the game so fast that we were running so many instances that they were just ran out of memory. So when we optimized the memory down, then we could fit a lot more onto these servers. And then to go through these kind of three-step process. We did a lot of measuring, the tick rate, the memory, and the CPU. We sent that to our telemetry service. Analyze, figure out which game modes use the most player counts, which one produced the best performance. Update, make changes. So we could say, hey, this instance type needs to run on a 10 multi-tenant, but this one needs to run on 1 multi-tenancy because it's just so slow to run. Maybe it has 100 players on it. So measure, analyze, update, and then repeat. And doing that, you can optimize your performance. But you want more tips. All right. Here's one. Migrate to Linux. If your server's running on Windows, it's close to double the cost to run a Windows server compared to Linux. And we found that when we moved to Linux, we could optimize a little bit more too. And that could produce the single largest cost reduction if you're at half the cost. I mean, that's great. And then our developers we were running on Unreal 3, so they had these kind of optimizations that they ran when they compiled that got us a lot of concurrency on our servers. One of the interesting ones is that do a tiny sleep on each frame. Apparently on the Linux task switcher, doing that tiny sleep, it seems counterintuitive to sleep, but doing that allowed the servers to share with the other processes so that they were a lot more conceding with having multiple. And then you can teach Linux how to make core files. Windows will automatically make crash dumps sometimes, but Linux, you gotta add this little bit of code the server developers did, then we started to get core files. But then you gotta rename the core files, because by default, Linux will make a file called core, and that's not very intuitive what that came from. So this little, this sudo bash -c echo was a kind of funny pattern we had to put. When you upload a build to GameLift, you can put a little install.sh file, and you can do your configuration there. So it wouldn't really let us update this kernel in the syscontrol.conf unless we did this funny magic spell to convert it. So once we did that, we were able to change that file, and now our core files had better names. So how can we use Zeppelin filter with multi-tenancy? So this is another trick. So we had some game modes that were, as I said, ridiculously fast, and some that were kind of pokey. So we made multiple fleets with different multi-tenancy configurations, and we used the Zeppelin filter to direct game sessions to the right fleet. So imagine that we have a server that supports up to 100 players. So at 100 players, it starts to get slow. And so we can have a 10-player death matches, or one 100-player battle royale, since that's the rage all these days at this time. So we have one server that has 10 concurrent processes and one that has 1 concurrent process. Zeppelin flies in there because that's what Zeppelin does. Let's use a game mode filter for the game mode. So if a player requests the deathmatch, then when it's a deathmatch mode, it'll go to the 10-server fleet. When it's a battle royale, it'll go to the 1-server fleet. It works nicely. But what happens if we have another mode that supports 10-player? Then it's not going to know what to do. It gets a capture the flag, and it's like, I don't know what fleet to send it to. So where does it go? Well, we could do a player count. So a player count equals 10, the 10-server fleet. Player count equals 100. So using these filters, we can use kind of any game property we can use to filter and send the player traffic towards where it's going to be the most cost-effective for us and the most efficient for players so that they have the best experience playing, so that they're not slowed down by servers that are running into each other. So one problem is, how does Zeppelin know which fleet is which? All we have out there is a name and a description for our fleet. So we could store the custom fleet config in Zeppelin, but then we'd have some data duplication because at Gearbox we have many environments, and an environment could last for a day and we shut it down, like a QA environment that we want to run. And we don't want to have to transfer all this configuration and say, well, okay, we need this fleet to go to this process. We could use tagging, but there's not tagging in AWS GameLift yet. Soon we shall have tagging. So this would be nice to be able to say, hey, this is a tagged light fleet and a tagged heavy, so we can use that tag to send our players to the right server. But we found a little trick. We can use the description field for JSON document tagging. The description field is huge. I filled it up with X's, and it wouldn't end. So we didn't need a lot of space for a tiny little JSON document that tells what our tags are. So in this example, we have a one server fleet that has a service PSN, title is reInvent, and the filter is heavyweight. And the other one is a service PSN, title reInvent, filter lightweight. So we can use these tags. When the Zeppelin worker reads this configuration, he sees the tags, he sees the description, he knows what these fleets are useful for, and he can filter the players to the right fleets. So filters are basically like little rules that we have. And so here's some basic examples. Heavy, player count is greater than 5. That means it's going to be a heavyweight server. Maybe players are take up a lot of load on the server. Light, player count less than or equal to 5. So we have the opposite. So in development, we can create and update and test new filters. So maybe in the heavy, maybe we're adding a social hub map, and we know social hub may have 1 player now, but it could support up to 100 players. So now the heavyweight could be the social hub. Maybe you have a tournament, and you want to send your tournament to your most powerful servers. So you can say the player role has a VIP, they go to the tournament filter. One awesome thing we could do is use filters to test A/B test content. So you could say, hey, we're having this problem. We don't want to enable logging on all our servers, but maybe some of them. So we added the ability to have random. So in this case, 10% of our matches will go to the extra logging fleet. It was very powerful. We did some really great testing to figure out like performance and stuff like that. So in our quest to entertain the world, we really need to entertain the world. We can't just entertain the local area that we're living in. So we need to have multiple regions. GameLift is available in a bunch of regions. This is their official document for all their current regions. And you can use those regions by just requesting a region, or you can do this really powerful thing they have called queues. That's another building block of Amazon, GameLift. So to configure a queue, you give it a name and a timeout. So the name says, hey, what's this queue name? Kind of like an alias name. You'd say, hey, this is the lightweight queue, and our timeout is how long you want to wait for a good server. So maybe you have a bunch of regions, and you don't want to make the players wait too long. So you have a timeout that says, hey, if I can't find one in a reasonable amount of time, I'm timeout, and I'll do something else, or send them to another region. And then you add latency policies. So you really want to balance this. So in this example, you can spend 10 seconds searching for a destination for 100 milliseconds, or where the latencies are less than 100 milliseconds, and then you spend 10 seconds searching for a slightly worse server, and then if you can't find anything, you spend the remaining amount of time to find 500 milliseconds. So you can stack these up and configure them and balance between how long the players are waiting and how good a performance you want them to have on their servers. So then you add your destination. You can use either a fleet or an alias as your destination. So in this example, the top one says USA East goes to the fleet, and US East also goes to an alias. So it'll pick between those. That's a bad example. It should be US West. But the performance at US East will be the same for the player. So how does this work? So each client will receive a list of all the different QoS endpoints that they can connect to. Now, the QoS endpoints are just the kind of standard API endpoints that Amazon has for each region. Each region has its own endpoint. So the client gets a list of those, and maybe US East is this endpoint, US West is this other endpoint. And we tend to use the regions that the fleet is deployed to, so we're not going to send them to Australia if we don't have any Australia servers. Then the client's going to ping each of those servers to figure out which one's the best. When it requests a server, it's going to ask in order which ones it likes. So it likes C, A, B. Now, it doesn't really need to do the order in this case because Amazon GameLift will figure that out for you. So Zeppelin will say, hey, we need this queue. We need a server in this queue. And here's all the players' latencies. So it'll collate that and figure out which is the best server for you to go. So it checks the light queue. It says, hey, here's a bunch of regions, and C is the best one. And you can see this example, this player likes C the best, so GameLift will send them to region C. And that's pretty powerful. We didn't get to use that, though. We were on the bleeding edge, so we didn't have queues when we launched. So we created this region of doom, I guess, if you will. It's very similar. It gets a list of regions. It's going to test each region. Now, the player is going to send the regions in order. And this is important because Zeppelin is now going to have to receive the list of regions in order and figure out which one the client should go to. So in this case, C is his favorite region. So he's going to request a server from region C from GameLift. And then if that's not available, as a backup, he'll try A. And then as B is his final if the regions are full or if there's some problems in the regions. In a multiplayer case, you're going to have a bunch of players sending it to Zeppelin, and he's going to have to compare and collate. In this case, you can see 2 players like B the best, so he's going to pick B from GameLift, then C, and then A. So what you want to do when you have a bunch of players is you want to try and make your groups based on those regions. So if you're a multi-region, if you make your groups with people from Australia, then they're going to have a better experience because all of them are going to be from Australia. If you have half from Australia and half from Europe, they're going to have a bad time. So access to data is something that's become very important to game development. We have a lot of players playing online, and we need to be able to visualize what the players are doing and how to optimize that so that we can figure out how the best to serve the players and make them happy. So there's a couple awesome APIs that Amazon provided for us. And these are great. They're so fast. Like within a few minutes of live, you get a live data of what's going on. This one's describe fleet capacity. You get a bunch of things back here. Fleet ID, instance type, desired incident count, like your scaling, minimum, pending, how many are terminating. The interesting ones for us, the most useful though, are maximum instance count, active instance count, and idle instance count. So this really told us, the maximum told us how many servers until we run out of servers, how many instances. The active told how many are actually ready to serve players, and the idle have 0 game sessions. Another one is describe fleet utilization. And I'm going to show you later how we visualize this data. It's really cool. Describe fleet utilization will tell us the active server process count and the active game session count. So we know how many server processes we have and how many game sessions we have. So if you remember, you can have multiple server processes per instance, and each process is going to serve a game session. So this is how we visualize it. This is great. You can see in this line that we have the green and the red lines are useful to compare. The green is the number of instances that we have, and the red is our max instances. So this is one of our lower utilized regions, but you can see that we're very far from reaching our maximum capacity there. So if we were to get up to 150, we'd have to raise our maximum. And that's something that you're probably used to most Amazon services having the ability to configure your maximums. GameLift has a nice configuration in the UI too that allows you to see your maximums. And another so you can see at a glance, you can compare those numbers and look and see that you're doing well. So another one is the light blue and the dark blue, the server count versus the game session count. And if you remember, each server is going to serve 1 game session. So again, if the light blue line reaches that dark blue line, we've ran out of servers for this region. And probably our scaling was to blame. And finally, nestled at the bottom where I like it, idle instance count is near 0. So you always want to keep your idle instances because they have sessions on there, or they have no game sessions on there, but you're paying for them. So it's good to keep them at 0. This is really awesomely powerful for us because if you track your active player count, you know how many players you have, you know how many instances you're serving. You can figure out your cost per player over time. You can say, hey, during this period of time, we're spending a lot more per player than we usually do. And you can figure out, you can make changes, optimize that, and come up with a better configuration that allows you to serve the players better and be much cheaper. So this is another one that we made. So we kind of had our own custom scaler at the time too. And you can see the light blue line is dangerously close to the dark blue line, around 820. So this is where I was, over the weekend, I was optimizing my scaler, and I was watching these graphs, and I was like, oh, I need to scale it. I was manually pumping it up during the launch of GameLift until I figured out what the problem with our scaling was. So our dark blue was not scaling up to meet the demand. And these real-time APIs allow us, and not real-time, but really close to real-time, allow us to really get close to figuring out what is going on in our infrastructure at this moment. So this is where I manually scaled. Now, I also made a couple of gauges. Now, these were really fun too. The first is the % idle instances. So as I said, we want to keep the idle instance down. So this one shows 3% idle instances, pretty good. Could be 0, but pretty close. Now, an idle instance means that it's hosting no game sessions. So it's about the biggest form of inefficiency. Like I said, you're just paying for nothing, right? You're getting nothing. So to get this calculation, I used from those data APIs before, I divided the idle instance count by the active instance count. Now, it may be a little misleading, but the terminology active instance count actually includes both idle and non-idle. So active in GameLift parlance means that it is a server that can host can have game sessions on it, but it doesn't necessarily have to have any on it. So don't get confused by it when you see active. So it could be available to host 5, but it's actually hosting 0. So it's actually really idle, but it's active. It's ready, I guess. And oh, there's a math box. All right. So, but don't worry, this is the simple math I got here. All right. So if we take our example, we have 40 idle instances out of 100 active. It's 40% idle. It's pretty bad. We're paying for all those services doing nothing. You may want to figure out why you're flushing money down the toilet. So ultimately, having an at-a-glance view of this data, I mean, we could just look at that and see, oh, we're doing good. It's in the green. Another aspect of efficiency is what we call server hosting. So a hosting server is one that is hosting a game session. Remember that there are a number of server processes on each instance. So an instance could have 5 server processes, but if it's hosting 1 session at the time, 1 out of 5, that's pretty bad. So this is another way that we can measure our inefficiency, hosting a game session. So a calculation, active game session count divided by active server process count. So again, those APIs, we're very easily able to see the real-time view of what's going on. Again, the terminology active server process includes both hosting and non-hosting processes. So, sorry, excuse me. Don't get confused when this is active. So here's our friend, the math box. Or is it our friend? Let's see. We have 100 game sessions out of 200 game servers. That's 50%. It's not good. And so why do we have 2 ways of measuring efficiency? Because they can each show a different aspect of how efficient you are. So in this case, we have 1 game session. It has 10 instances divided by 100 game servers. is 10%. So 10% of our servers are hosting. Now, if you look at the idle count, that's going to be 0% idle because each instance has something running on it. So one of the main reasons to run your software in the cloud and running games as a service is that you can scale to any load. So thankfully, Amazon has built-in free scaling. You can do rule-based scaling. You have a bunch of options available to you. If activating game sessions, active game sessions, available game sessions. It's quite a range of options here. We didn't have all these options available to us, but you could have an emergency policy that says, after all the rules, if you have a queue depth greater than 0, then scale up. So you can scale as an emergency based on your queue depth. And you can do for any minutes, scale up or down by percentages or by instances. So this is great, but you configure it, you give it a name, you configure your rules, and you can add a bunch of these rules, and they'll each run in order until it finds when to execute. And it'll automatically, it won't run the rules over and over again. So if it triggers a rule, it's gonna not re-trigger it over and over again and make you scale up a lot. So let's talk a little bit before Amazon GameLift. We scaled based on maintaining a fixed number of idle instances. It's fast, easy to configure. Excuse me. But it was expensive. We were paying for all these idle instances. So if we said, hey, we need 20 idle instances, we were paying for those. And so given this fictional example, so if we had 50 active hosting instances and 20 idle instances, and each instance hosts up to 10 game sessions. So let's do some math here. Hopefully it's simple, and hopefully it turns out we're saving money. So we're paying for 50 instances plus 20 idles. We're paying for 70 total instances. Let's look at our gauges. Remember I told you the gauges were a good way to measure your efficiency? So let's look at what our gauges would show for this, this configuration. So we've got 20 idle. Divided by 70 total instances. So our idle gauge says 29%. Not great. We have 29% of our servers doing nothing. How about our percent server hostings? We actually don't know how many game sessions we're hosting. Because we're scaling based on idle, it's always going to have 20 idle, no matter how efficient we're using the rest of our servers. So we could have up to 50, we could have as low as 50 or up to 500 game sessions that we're hosting. And we have 700 total, because we had 70 instances and 10 on each. So our efficiency is 7% to 71%. Now, after Amazon GameLift, I mean, that was really efficient. We were really paying for a lot of idle instances, so it was really bad. After Amazon, we scaled based on maintaining a target percentage of servers hosting. Remember that other gauge? So here's our fictional example for this one. If we have 50 active hosting instances, and we're going to have 0 idle in this case because we're not maintaining any idle. We don't want to have any idle instances. And each instance, again, hosts up to 10 sessions. And we want to maintain 80% of our servers hosting. Mathbox, he's going to come back. Hopefully this time we're gonna win this time. I'm betting on this one. So in this case we're paying for 50 instances, 0 idle, and we have 50 total instances. So here's our gauges: percent idle instances, 0 idle, and we have 50 total. 0% idle instances is perfect. That's a great measurement. But we still have the other one to look at. So percent servers hosting, we have 400 game sessions. In this case, we know how many game sessions we have. Divided by 500 game servers, because we're maintaining 80%. So 80% of 500 is 400. So really 80%, it's a self-fulfilling prophecy. This graph is going to be 80%. And the good part about this is that we're actively scaling based on our efficiency. So we're scaling to make sure that we're going to pay the least amount for our services that we're running here. So this, after GameLift, we had a huge savings, and we're using every single bit of these servers that we could. Zero idle. Every server is running something, and 80% of our servers are being used. And that 100 is used for scaling. So if we have a surge of players, of 400 game sessions, and we get another 50, we have 100 to serve up those scaling, and allows us time to scale up our instance count. So needless to say, well, I'm going to say it anyways, this is a huge cost saving, and no idle instances, right? We have a lot of control over what we're paying. We can control how much we're paying. We can control, and no idle instances. We use the APIs, same APIs. We had a new one, update fleet capacity. So that one allows us to actually modify this. So we're looking at this in real time, and we're modifying it in real time. And Amazon's great. They provide all those APIs for us so that we can scale our servers based on instantaneous access to the data. Now, there's more benefits to this. So our scale capacity increases as our load increases. So math again, if we have 100 servers, 80 are hosting because we're maintaining 80%, we have a 20 buffer. So we can have 20 servers to scale up as players come in. If we go up to 1,000, we have 800 hosting, there's a 200 buffer. So we're paying exactly how much we're using, we're controlling how much we're paying, and we're scaling at the same time. And the more players we have, the more capacity we can handle. And we implemented this ourselves, but you can do this with the scaling built in with Amazon now using the % available game sessions. You can use that in a rule, and you can get this really cost savings for your GameLift servers. Now, troubleshooting before GameLift again, access to logs was really painful. We had a complex manual process we had to go through, and we had to kind of go through all these. I'd go through the steps with you, but it was just so tedious that I would cry. So it required documentation. The files were so large that sometimes it was like finding a needle in a haystack trying to find the log that you needed. To add insult to injury, though, that even if I had the time and took the time to go through the steps, that there was a good chance that either the server was already shut down or got deleted or the logs got rolled over. I still might not have access to those logs. So stop me if you've heard this one before, but along came a GameLift. GameLift automatically archives all your logs to S3. It's stored for 14 days, it's zipped up so it's compact size, and you can get it very easily. You can download it from the web console. Just log in, click on your game session, download your logs. Select the session, just a button, click the button. The problem is it's not easily searchable. So they have an API for that. So you can call the get game session log URL, it's scriptable. You need the game session ID, and it gives you a URL that you can use to get your logs. So I thought, hey, we have a tool already that looks at our servers and sees what's going on in our system. What if I could just embed that? So I just embedded the logs. So this tool that our developers were already using, our support was already using, they would log in, see their match, see it failed, click on the logs, download the logs. It was just self-service. They didn't have to call support anymore. They didn't have to call the developers. You can just embed this right in your app. Accessible by developers, testers, support. Now, a creative use that we had was that our new title has really small replay files. It's 1v1, so there's really small replay files. So in development, we print these to the logs. So now when a tester says, hey, I got stuck on this wall, or I shot this weapon and I blew up something I shouldn't, we can just go look at the replay file and click on it, and it's right there. So how do you get started with GameLift? There's a sample game. Now, I kind of discounted this at first, but the sample game, it's just really quickly, you can just click through these 5 steps and get a game server up and running and really see the whole infrastructure as it's working. The server SDK, there's 5 or so things you need to do. Somewhere in your startup called init SDK, Very simple. Implement a callback on start game session, on process terminate, implement a small bit of code there. You may want to do some extra stuff there. This is just kind of example code. On health check, so GameLift's going to be constantly asking your server for its health, and you can say, hey, am I healthy, am I not? And then when you're ready to start hosting game sessions, you can call process ready. So once you do those 5 things, it's really simple to get your game servers integrated into GameLift. You can use any engine, Unreal, or any engine. I mean, they have plugins for Unreal and Lumberyard and Unity, but you can use any engine. And the last thing that made things really easy, and our server developers love this, was the GameLift local. It's just a Java program they download and run on their server. And it runs on your workstation, it emulates GameLift, and it supports Windows and Linux. So they were able to download this, run their server, and test their server code without going through the process of building and uploading and getting a game fleet up. So it was really fast, and they were able to really iterate, make the servers, figure out what's going on. And you don't have to deploy after every tweak. This is some really good stuff. So in conclusion, Amazon has been a great partner for us during this transition. We made a lot of changes. They made a lot of changes for us based on our implementation needs, saved a lot of money. We could tell that GameLift was created for the gaming industry. They had a lot of just things that were just right what we needed. And it's just a small, it's really cost effective. It's just a small amount more than running the servers yourselves. And we ended up saving a lot of money on our operational costs, our scaling. Everything ended up, it was a really great experience. And our players loved it too. They had a lot of good things to say about us, the ones that really dedicated players. We tried to focus on the player experience, getting them in and out of games fast. So GameLift is games as a service. Games are a service, and game developer, we provide that service for people. It's a magic trick, really. And we're like magicians, taking technology, taking GameLift as a technology, and transitioning in the blink of an eye into entertainment. Entertain the world. And using these techniques, you too can entertain the world. So if there are any questions, you guys can go to the conveniently placed microphones. And then also, if you guys give me your business card, I promise to not spam you, and I can send you some shift codes for any of our games. So thank you.